Happy Monday, everybody. Today we're going to talk about the history of the atom as a little review for our quiz tomorrow. Um, we did really well talking about the atom in the beginning. We talked about way back in the times of ancient Greeks, Democritus, about over 2,000 years ago. Just imagine the idea that there was something so small that it couldn't be caught. And that's where we get the word atom from. So the history of the atom starts all the way back 2,000 years ago. And they use the word atom as describing something that can't be divided or uncuttable, and we talked about that several times in class. You guys did really well in understanding that. Now, it took thousands of years up until that point that we really tried to get a handle again on what atoms were. The next kind of major breakthrough was with Dalton in 1805. And Dalton really put together the idea of elements and atoms were linked together. The idea that elements were made of atoms, that elements of the same type had atoms that were the same. So you met the idea that hydrogen always has one proton. That goes back to Dalton. He didn't know what protons were, he didn't know what electrons were, but he imagined that those atoms of the same elements were really similar to each other. He also imagined that atoms of different elements were different from each other. He didn't know how or why, but that was where his thought process was going. That led us forward until we actually started figuring out what some of those subatomic particles actually were. And so in 1897, Thomson really made a big breakthrough, putting electricity through some gas. He saw some charges come off, and this really gave us our first glimpse at what made atoms up. And so we now call these things that he found electrons. So Thomson in 1897 found for us the first particle of an atom, the electron. Now he rightfully thought that there must be some positive part to it as well if there was a negative part. And he imagined that the atom looked something like this. He called it the plum pudding model, where the positive charge was all around and these small little electrons were floating around in this positive soup or pudding. And that held for quite some time until the next scientist in 1911. Rutherford made a major breakthrough. He was using alpha particles. Didn't know that they were alpha particles at the time, but he was using them to shoot at some gold foil. When they hit the gold foil, what he found was most of them bounced off in different directions. 99% of them went through, though. 1% actually hit something and bounced back at his emitter. And this really made the idea of the plum pudding kind of fall apart. If atoms were positive throughout, they would hit lots of things, and lots of these particles would bounce back. But it turned out that 99% of them went through, and so what that meant is the atom was 99% empty space. And so Rutherford really gave us the idea that atoms are mostly empty space, and at the center is this dense positive area called the nucleus. In just a couple years later, Niels Bohr took that information. He wasn't really interested in the nucleus. He thought the nucleus it didn't really change over billions of years, and a lot of the interesting chemistry happened with the electrons. And he imagined the electrons were in these things called electron shells. Imagine them like planets orbiting around the sun. He imagined that the first orbit could hold 2 electrons, and the second orbit, the second shell, could hold 8 electrons, and then the third orbit here could hold 18 electrons. In class, we've only had it hold up to 8. And that's sufficient to get up to argon, but it can hold all the way up to 18. Now, all these theories put together are part of our modern understanding of what the atom looks like. We know that the rings that Niels Bohr imagined weren't quite correct. They're actually much more complex, and they're not two-dimensional. It's not on a flat surface of rings going around, but there's a 3D space that these electrons can go into. So these orbits are much more, at least interesting now. Interesting shapes, and they're found. And we also understand that electrons can be found in lots of different places. And these pictures show us places that they're likely to be found, but we know that they're zipping around so fast and pushing against each other that they can be found in lots of different places. And so in modern chemistry, we refer to them as the electron cloud, and we talk about the possibilities of where electrons can be found, understanding that they're moving so fast and changing so much that it's really hard to figure out where they actually are. Well, I hope this helped you guys out, and hope you guys do well on tomorrow's quiz on the history of the atom. Good luck, guys.